This question is another one involving the application of derivatives, and it also involves the understanding of graph. So a particle moves along the x-axis, and the graph of the particle's position xt at time t is shown in the figure. So this line is basically the position of the particle. And it says the graph has a horizontal tangent at t equals to 8 and points of inflection at t equals to 2, 4, and 6, and 10. For what values of t is the particle speeding up? Now notice the wording here. It says speeding up, which means it can both accelerate in the forward direction, but it also can accelerate in the backward direction. So if we want to determine whether it's speeding up or slowing down, we need to look at the speed or the velocity of the particle, and also the acceleration of the particle. And from previous lessons, we can understand that v, the velocity of the particle, equals to the first derivative of position, and acceleration of the particle equals to the second derivative of the position. And if the particle is speeding up, it means the sign. For example, if velocity is positive and acceleration is also positive, then the particle is speeding up. Or if the velocity is negative and acceleration is also negative, the particle is also speeding up, but it's just at a different direction. So now we need to split the graph into several parts according to the important values, which is the points of inflection. So for the first part, from 0 to 2, we can see that the velocity, which is the graph, the slope of the graph, is decreasing. So for this part, velocity is negative. And this shape means concave down, which also means that the acceleration is also negative. The second derivative of the graph is also negative. And this means that the particle is indeed speeding up in the negative direction. So our answer should have this interval. Next is 2 to 4. Now, if we look at the slope of the graph, we can also see that the velocity is still decreasing. However, this shape means that the graph is concave up. And concave up means the second derivative is actually positive. And if the velocity is negative while the acceleration is positive, it means that the particle is slowing down. So this interval is not correct. And 4 to 6, we can see that it's basically the same thing as the 0 to 2 section. So this one also works. And 6 to 8 is similar to 2 to 4, so this one does not work. And from 8 to 10, the velocity is positive as the slope is increasing. And this shape means the graph is concave up. And concave up means the second derivative is positive. So both the velocity and the acceleration is positive. So this section from 8 to 10 is speeding up. And from 10 to 12, the velocity is still going up. However, this shape is concave down, so the acceleration is negative while the velocity is positive, and that means from 10 to 12 is actually slowing down. So our answer should be 0 to 2, 4 to 6, and 8 to 10. 0 to 2, 4 to 6, and 8 to 10. So C is our answer.